greater than 0? Meaning, like, I guess first of all, where does it equal 0? Maybe that's an easier thing to start with.
At the like x-axis.
So this
Whatever.
place right here is where it equals 0. But everywhere else, do you see that the graph is above?
Yeah.
Okay. So everywhere else besides 3, the graph is above 0. So I'm sort of pausing there, just seeing if there's any confusion or anything's unclear about that.
It's fine.
So here's let me just give you the summary. The summary here is that this is always greater than 0, except when x equals 3. So it's everything but x equals 3. What do you think of that?
I can comprehend that.
Okay. So the answer in terms of like, well, what is the answer? You guys using set builder notation still? Is that right?
Yeah.
So it would be like x such that x is an element of the real numbers. X cannot be 3. You're saying that it's everything but 3 that makes this true. And
So,
that's why I was going to the number line. We just finished that thought here.
no.
Is at 3 it's not true, but everything to the right of 3 is true, and everything to the left of 3 is true. And this is essentially an exception problem. That's why I didn't want to start with it. But maybe there's clarity here. If you got a question or two, let me know, so we can try to answer that.
Huh?
Do you have any questions or any follow-up to that?
No, but is a set builder notation just like domain and range?
Yes.
Okay.
So if you got another question, you let me know. I'll write it down. We'll work through it.
That's fine. That's the only question I had.
Oh, that's it? Nothing else for the,
Yeah.
I'm sorry, I meant like, what's the next one on the worksheet? Sorry.
Would you like me to type it in chat?
Whatever's easiest for you. If you want to say it verbally, I'll write it down, or you can type in the chat.
It's x plus 10 is greater than or equal to 4.
Like this?
Yeah, but with the x or absolute value bars.
Absolute value. Okay. All right. Great. So the absolute value of x plus 10 is greater than or equal to 4. Okay. So and you do have to graph this again. Is that correct?
Yes.
Okay. So let's start with the graph. All right. And let's start. I guess the way you guys are doing this is very awkward. When you say graph, you're talking about like, were you doing them on XY plane in class?
Yeah.
Okay. That's fine. All right. So the graph of this x plus 10 means that it's got a vertex at minus 10 comma 0. So you go left 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 right there. Okay. And then the a value in front there is the 1. So it's got a shape of this to the right, by symmetry shape of that to the left. Is that okay so far?
Yeah.
So you're literally looking at it as y equals absolute value x plus 10. And on the right here, you're looking at it as y equals 4. Can you tell me what that looks like on the graph?
Wouldn't you put a line at where 4 is on the y-axis?
Yeah, it's a horizontal line, y equals 4.
It would be the y sub 2, correct?
You can do it that way. You can use subscripts to denote the differences between them. So here's a more descriptive way of an answer of what this is asking. It's saying, where is the graph of this one on the left above because you can think of greater than or equal to as above the graph of 4. And you can see that there's kind of these breakpoints or these in-betweens where it intersects. So it's like, where is it above? Where is it not above? Okay.
Wouldn't you have to solve to get those points?
You can, if you graph it really well, and I've done kind of a terrible job of doing that, but if you graph it really well, you actually can use the X values for that.
Yeah, he gave us one where it's just like tiny graphs that you put the numbers in by yourself.
Yeah. So the answer is depends on how good you are at graphing. Okay.
Mhm.
Now let's do it by hand to verify that. Okay. So we know where they equal is at -14, -6, but let's see how to do that by hand. Okay. So to do this by hand, to figure out where they intersect, you set the absolute value x plus 10. We just look at the equal to in this case. So there's two cases. There's x plus 10 equals 4, x plus 10 equals -4, like that. Okay, and could you solve these equations for us, please?
Yeah. Would it be x equals -6 and x equals -14?
Yes. And that's consistent with the graph here. So if you were supposed to show where they intersect, which you kind of are in this, it would be the point -14, comma 4 and -6, comma 4. The 4 comes from the y2.
Oh, okay.
Okay. But in full disclosure, we don't actually care where they intersect as much as we care about where it's greater than or equal to. So that's where, I mean, that's really where the focus of the lesson should be today, which is how do you solve something like this? Okay. And I call this the outside case. Okay. So you end up writing two different inequalities. Okay.
Mhm.
You write x plus 10 greater than or equal to 4, x plus 10 less than or equal to -4. So there's two things that you do for the one on the right. The first one on the left here, it's exactly the same as the way it's written with just a dropping of the absolute values. On the right, you flip the inequality, which I think we maybe looked at, I'm not sure, and then you negate the number.
Mhm.
Is that okay?
Uh, yeah.
All right. So did you see this in class?
No.
What are they doing in class? All right. All right.
Well, to be fair, he is supposed to be a science teacher.
Okay. All right. Well, so we're just gonna get a little bit. We're gonna get a little bit more today than you got in the classroom, which is good. I'll help you when you're in there next time. Um, you're gonna subtract 10 from both sides of the equation. So you have x greater than or equal to -6, x less than or equal to -14.
Mhm.
So on a number line, here's what this looks like. This is where you got to be careful here about where you put the numbers. -6 is more to the right of -14. So it's to the right of -6, and it's to the left of
Negative.
-14. Okay. So it's all the numbers. It's all the numbers less than -14 or all the numbers greater than or equal to -6.
This
And
is what he was trying to do in class like yesterday or today, I don't know. But he wasn't explaining it right because it was our bell work and he just goes, "Okay, here's some absolute values. This one an and or an or, an and or an or." And how he explained it was Venn diagrams and if
yeah,
they intersect or not.
yeah, I think that's a bit of a reach for you guys. But hopefully this way is clear. The bell work should help you though. It should help you with the stuff you're learning for the day. So we'll go back to that set builder notation x such that x is an element of the real numbers. And like I just said, you have to write something like x is less than or equal to -14, or x is greater than or equal to -6. Now we're going to go back and look at the graph as well. Let me know when you get all this down so we can look at that.
Okay. I got it.
Got it? Okay. Now we go back and look at the graph. Like, what does that mean graphically? It means everything to the right of this -6. So basically the graph, if I could just shade it here, it's like everything to the right of it, everything to the left of this one.
So technically just everything above those 2 points.
Yep. Including those points, because that's where it's equal to. But everything above it,
Okay.
well, we can definitely do another problem here. If you either want to give me one, or I'd like to do one more that's like this, greater than or equal to. If you've got one like that or greater than, do you have any more like that?
But these ones are confusing. It has A as 3, and then inside the absolute value bars, it just has an X, and outside of it, it's -1 is greater than or equal to 2.
All right, so I missed some of that. You said what goes to the left of the absolute value?
Um, the left, there's a 3 as the A, and then on
Got
the
it.
right, it's -1 is greater than or equal to 2.
Okay, so does this look as reasonable as it could be to match that? Is that what you have written?
Yeah, yeah.
Okay, awesome. Okay, so the way this is read, it's 3 times the absolute value of x -1 greater than or equal to 2. Okay. All right, so our goal here, I guess we're again going to graph this. So we're gonna, on the right here, we're gonna treat this as y equals 3 absolute value of x -1. And what I didn't understand, but I do now, is you were saying the a value is 3, and that's really important because
Mhm.
we want to what am I doing here? That's too much. Okay, that's okay. We want to graph this. So the vertex here is at 0, -1,
Mhm.
like that. Okay. We can spend a little more time doing that in a bit if we need to, but let's just go with it for now. What is the slope from this point?
Um, 1/1?
So it's the a value. The a value gives
Oh,
you the,
3/1.
yes. So that means rise 3, run 1. So it's going to go up 3, 1, 2, 3, right 1, like that. And draw, a couple points there, good, enough to make it look reasonable. And then use symmetry to get the ones on the other side, like that. And you mentioned that before. We can call that y1. Y2 is just 2. So you're gonna graph a horizontal line at 2. That was not very good. Let's do better. Something like that. Y2 equals 2. Y1 equals 3. Absolute value of x minus 1. The greater than or equal to means it could equal it or be above it.
Okay.
So can you maybe tell me visually where you see that, or kind of, I don't know, somehow describe that in any way? I'll take.
Which one?
Well, I'm trying to get you to tell me where it's greater than or equal to than 2. Where's the v greater than or equal to 2 here?
Um, everything on the left from like the points where it meets the y sub 2 and everything on the right from where the other point meets it.
Good, good. Yeah, I like that. I like that. That's good. So we can be a little bit more specific though. Can you tell me the x value at each of those positions where it intersects?
Um, 2
That's the y value.
negative.
That's the y value. You give me the y value too. The x
Okay.
value.
1 and negative 1.
Yes. So it would be the ordered pair might be like 1 comma 2. Might write that. And then negative 1 comma 2 like that. So those are the ordered pairs where the two intersect.
Okay. It's hard to see that from my graph because they don't have the lines.
I see. Okay. All right, now let's do this the more traditional way, which is to actually just solve the equation here. So we'll just restart it, reframe the problem here. So your goal here is to isolate the absolute value of x, or really whatever the absolute value is. If it's like absolute value like x minus 1 or plus 1 or whatever, you want to get that by itself. So we've got multiplication by 3, subtraction by 1. Which would you undo first?
Subtraction of 1?
So you're going to add 1 to both sides. 3, absolute value of x greater than or equal to 3. How do you undo this 3 in front of the absolute value of x?
Divide it on each side. Divided by 3
Good. So the
on
absolute
both
value of
sides.
x greater than or equal to 1. So this produces two possibilities. It's the possibility that x is greater than 1, or this is where you have to flip the inequality and negate the number. So always two things there. Flip the inequality and negate the number. So on that number line, and so this is the kind of the traditional way of showing it. I sometimes like to show it differently, but typically the one on the left here is the number that's out on the right. So there's 1, not to scale here, there's negative 1. All the numbers bigger than 1.
And then the same for the left.
Yes, all the numbers less than negative 1. And the reason it's an or is because they don't have to both be true. Just one has to be true. It could either be in this region or in this region on the right. That's okay. So if we go back and look at the graph, let me know when you get this down. It is consistent with what we said on the graph or showed on the graph.
I got it down.
Okay, so if we go back and look at the graph, you said it for you, like you're like it's everywhere except where until it hits this point, and that's true. It is. It's all the numbers to the left of negative 1 and all the numbers to the right of positive 1, including those numbers.
So if we did that on the number line, would it be closed or open circle?
So the answer to that is based on the symbols. So these symbols always go with filled in. Let me get the orientation right there and there. They go with the open one.
Okay. I got that.
Great. Do you have another problem you'd like us to work on today?
Mm-mm.
That's it?
Mm-hmm.
Okay. Let me give you some to try here. So let's just try, and no graphing. The graphing, it's really not, we're not doing that, right? Let's just solve the inequality. So let's say it's something like absolute value x minus 1 greater than 5. Okay. I want you to tell me the two cases. What goes on the left here to solve? What goes on the right here to solve?
So wouldn't the left be x minus 1 is greater than 5?
Yes.
And then on the other side, it would be x minus 1 is greater than negative 5?
you flip the inequality. So maybe you
Less than.
wrote through it. Yeah, less than here. Okay. All right. So you're gonna add 1 to both sides. X is greater than 6, or add 1 to both sides. X is less than -4.
Okay.
All right. So ready to try one on your own?
Yeah.
Okay. Let's go absolute value 2x minus 1 greater than 3. Go ahead and try this one on your own, please. Give me the final answer on there.
For both.
Yes.
Would it be x is greater than 2 and x is greater than or x is greater than 2 and x is less than -1?
Okay. That sounds pretty good. Let's just let me work this out here in case you want to look at it later and see what's how you did this. So you flip the inequality and you negate the number there. So do you have that written down?
Yeah.
Okay, so now you're going to add 1 to both sides. Add 1, so it's 2x greater than 4, 2x less than -1. Divide by 2, divide by 2. I'm sorry, this is -2 on the right. I'm sorry. So that is consistent. That is exactly what you said. Very good. All right, so let me come up with a slightly more difficult problem here. Actually, we didn't do enough of this. Yeah, we need a couple more of these. Okay, let me go find a few.
I almost got that one wrong because I was like, it's 2x is greater than 4, and I was like, wait, no, you have to divide by 2.
Yes, you have to get just x there by itself. All right, let me see here. Okay, that's not a good worksheet. Just looking for another problem, a couple of problems here for us to do. All right, well, I'll just make one up here. All right. All right, so let's go -15, absolute value greater than -3, absolute value 4x minus 2, like that. Okay, so this one's got a bit more to do, but it's the same idea as the previous problems. You want to isolate this absolute value, so you have to undo stuff until you get to where it's isolated. So if that's not clear, let me know. But give this a try. I do think you actually can do this problem on your own.
Would you add 15 to the both sides for the
Yeah.
first step?
Yes.
Would you divide 4 by both sides?
Yes. You have to get you have to get it down to the absolute value greater than or less than, depending on the problem number. You cannot make any, you can't do anything to split it apart until you get that.
So would it be x is greater than 5 and x is less than -1?
Sorry, one more time. X is greater than 5, X is less than -1. Is that what you said?
Yes.
Yes. So it's an or, the language here, kind of important. But let's just go through the steps here. So let's see, divide by 3. So you're right. X minus 2 greater than 3, X minus 2 less than -3, and your answers are correct. X greater than 5, X less than -1, like that. Okay. Very good. All right. So we should move to the other case. So we've been talking about the outside case today. And when I said outside on the number line, it's like this is what I'm referring to as the outside case. The next possibility is the inside, or maybe a better word is between. Okay. We were using the word or up here, and this one will be the and. So it's kind of like your bell work.
Okay.
Right.
I understand how that works.
Great. So let's do a couple of problems here and see how much, because you probably have seen this before. So another type of problem you might see is something like the absolute value of 5x is less than 30. Okay. So notice the difference here is that the inequality is going the other direction. And all the other problems we were doing, it was going to the right, it was greater than, now it's a less than. So this is the between case. So you do a couple of things here. You do write exactly what's written, but then you take that number that's on the right, negate it, and put it there on the left. Have you seen that before?
No.
Not in a previous class?
Mm-mm.
Okay, so this is just a little new. We got plenty of time here to do a bunch of examples like this. To solve this inequality, and this is considered what's called a compound inequality because there's more than one inequality symbol. You divide by 5 in all 3 places. Okay, so this is saying -6 less than x less than 6. All right, so on a number line, the big reveal here is that it is between these two numbers.
Okay.
Okay.
So would just the -6 is greater than x less than 6 be the answer? Just that?
Yes, that's your answer. That's your solution space. Now the way this is read is x is between -6 and 6. Yeah, we often do things in English that don't make sense, but that is how we read this here. Right. So the key difference is when it's a less than or less than or equal to, you write exactly what's there, but you also have to include the negative of this number here.
Okay.
And you might be like, why? Well, this is just the nature of these problems. So, all right. I'm just looking for another one here. This one looks good to try. Okay, it says 3 absolute value, 3 times the absolute value of x plus 5 less than or equal to 6. So because it's a less than or equal to, that is a between type problem. All right. What you have to do though is you still have to isolate the absolute value. The absolute value. So just like in the previous problem, see how the absolute value is already isolated. Just like in the one I asked you to do here, no matter whether it's greater than or less than, you have to isolate the absolute value. Okay, so it's first divide by 3. Absolute value of x plus 5 is less than or equal to 2.
And then you would do like both the cases.
So yeah, so you would it's really together, so it's not really cases this time. It's between. So it's exactly
Oh,
what's written, and then -2 less than or equal to this.
would you flip the sign?
You keep it in the same direction. These are always going in the same direction in this one. So if you go back and look at the previous problem, see how they're in the same direction.
Mhm.
Now, if you're confusing that with the ones we did earlier, again, it's greater than, greater than, greater than. So like if I just, I know I'm scrolling a lot, I'm sorry about that. When you were given an absolute value problem, your first decision is it a greater than or greater than or equal to, or is it a less than or less than or equal to? This
Mhm.
dictates how to proceed. Like that's how your thinking is. Am I running a sprint or am I running a longer race?
Okay.
All right. So now from here to solve this one that we've been looking at, you said you hadn't seen these before. Whatever you do to isolate x, you have to apply to all 3.
Mhm.
Right. So it's -7 less than or equal to x less than or equal to -3.
I've got it.
Okay, so let's have you try one here. Won't make it super difficult, but let's have you try a couple here. Let's go absolute value for x -1 less than or equal to 15. Okay, so go ahead and try solving that and let me know what you come up with.
Would you divide 4 by both sides? Or would you do the thing you did earlier?
Did you isolate the absolute value?
So, or add 1 to both sides?
Yes. Yes. You can't do anything inside the absolute value until you break it apart. Until it's gone, you can never like divide, add, subtract, multiply, whatever's going on in there.
So wouldn't it be the absolute value of 4x is less than or equal to 16?
Yes. And this is where you have to write out the compound inequality.
How would you write that out? That's where I got stuck.
Okay, so just like in the previous problems, you write, do you see I wrote x plus 5 less than or equal to 2? Let me show you here. Do you see that this part is exactly the same?
Mm-hmm.
And then you bring this number down but negate it.
Okay, so like
So let's do it together.
basically negative 16?
Yes, 4x is less than or equal to 16, but then you also put -16 there on the left.
So would you subtract the 4 from both sides or the 16?
You look at where the x is, and that's your focus. And what is the math operation between the 4 and the x?
I don't know.
They're squeezed together. So here, let's put it another way. Do you see this symbol there? Do you see a plus between the 4 and the x?
No.
Do you see a minus between the 4 and the x?
No.
So those are out. Do you see a fraction bar?
No.
So division is out. So what must it be? What's the
Multiplication.
multiplication? Yeah. So when they're squeezed together, that's multiplication.
Yeah.
So how do you undo multiplication?
Division.
Division.
So would you divide all sides by 4?
Yes.
So would it be -4 is less than or equal to x, or x is greater than or equal to 4?
Yeah, or would say x is between -4 and 4.
Okay. Sorry, the language is hard for me to catch on.
I understand. Yeah, it's the reason I'm saying it that way is because you don't read it. We don't read it the other way this is read, which I think is more awkward, is to say x is greater than or equal to -4 and x is less than or equal to 4.
Mm-hmm.
I think that's more complicated than
X is between.
x is between. Yeah. Okay. Let's try another one here. We actually probably have time for one more. That's okay. We've done a lot of problems tonight, which is good here. So let me just grab one more. Keep this one kind of basic. Absolute value x plus 1 minus 3 less than or equal to 7. Okay. Why don't you try solving this one for us? Ask me questions along the way if you've got them.
So if it's x plus 1, would we subtract 1 from all sides?
Yes, but did you write, so before you answer that question, did you write x plus 1 less than or equal to 10? And then on the left here, -10?
Yeah.
Good. So yes, you do subtract 1. It's the same everywhere. Whatever you do, whatever you're used to doing, you just do again here. There's no distinction there between that.
So x is between -11 and 9.
Yes. Very good.
Yay.
All right, let's go ahead and stop the lesson here for